Okay, so now at 11.2 we're going on to volumes now of prisms and cylinders. Okay, so two different styles of polygons, so two different formulas. Okay, so the volume of a prism, they give you the formula here. All right, it's B, capitalized B, which is the area of the base times whatever the height is. Now some of the diagrams, like the one on the right, it's a cube, so it's going to be a square, is going to be your 2D shape, so it doesn't matter which side you pick, you're going to get a base. But when you get a prism, a triangular prism like you've got here, go with the wording, it's triangular prism. So the base is the triangle, and obviously the area of a triangle is a half base times height. But be careful, because look at the difference. On the area of a triangle, the little b stands for base. Okay, but on the volume, the capitalized B is the area of the total base. So, you know, two different bases, two different letters. So capitalized B means the area, lowercase b is a length. Okay, so find the area of whatever the base of this triangle is, which will give you 60, and you multiply it by the height, which in this case is 11, and you finish up with 660. Make sure you put it in its units again, centimeters cubed. Alright, and again, just like we did in the area in chapter 10, we skip a few examples, so I put them together. So in example 3, volume of an oblique solid. Okay, but the formula is still the same, but don't forget the height has to be the perpendicular height, while in an oblique shape it's basically at a slant, so you need to find the outside height, the perpendicular height. Now the base, actually in the diagram it tells you that the base is 17.3, so it's just a case of substituting in and you get 110.72. And again, go back to the question, is it one decimal place, or like this example, two decimal places? So let's have a look at example 1. Basically what you've got is a toblerone or a tent. So the base is going to be your triangle. It's a triangular prism. So again, it's the area is going to equal the area of the triangle multiplied by the the base times the height. So you can, again, it's all this you can put in a triangle in your calculator. So a half base times height, well, the base is 6. The height of the triangle, don't forget, it's perpendicular height, remember, has to be 4. Everything is being multiplied together. So again, you can multiply by 9. You can put it all into your calculator and you finish with 108. And again, put the units in this case it's centimeters squared. Alright, so let's have a look at one of these oblique prisms. So let's have a look at question number 3. The formula still stays the same. The area equals the area of the base times whatever the height is, and don't forget perpendicular height. The area of the base in this diagram is going to be 2.5, and you're going to multiply that by 4.9. And when you finish, you're going to multiply that by 2.2, which is what they've given you. I mean, if you put all that into your calculator, because they're all multiplying anyway, so you can just put it all into your calculator and you finish up with 218.4. And again, units, meters squared. So let's have a look at the difference between a prism and a cylinder. Well, the formula still stays the same. It's still the base times the height, but now obviously it's a circular base, so it's pi r squared times whatever the height is, okay? And again, make sure you realise that, don't forget, from example number 2 here, for instance, the 9 is the diameter. So the first thing you've got to do is divide that by 2 to find the radius. So pi times 4.5 squared times 5 is 318.1. Okay, and again, remember that everything in the formula is being multiplied, so you can put it all into your calculator. Make sure you put it in parentheses. If, for instance, the 4.5, if you need to square it. Some calculators you don't have to, but I just just get used to putting them in parentheses. You're good to go. Alright, so let's have a look at number 5, because this is example 2 and example 3. Finding the volume of the cylinder. Again, don't forget it's base times the height. So in this case, A is going to be pi r squared times whatever the height is. Okay, pi obviously doesn't change. The radius, the diagram gives it you in the radius, so that's going to be 3.7 squared. And your height is going to give you 4.8. And if you multiply them together, you finish up with 206.4. And again, units, in this case, feet squared. Alright, so in example 4 now, what we're going to do is compare the volume of two boxes. And in this example, what's missing is the length of both of them. Okay, and what, again, look at the statement. It tells you the volume of box B is 150 inches greater than box A, and what you need to find is the missing length, okay, of each box. So let's have a look at what you've got. All right, so first and foremost, they've told you that box B, the bigger box, is whatever the volume of the bigger box, subtract whatever the volume of the little box must be whatever the difference is, which is 150. Well, in both boxes we're missing the length, so they've used L for that, but if you want to use X, that's up to you, but in this case let's use L. Don't forget the formula is the area of the base times the height. Well, the base in box B is length times width, so 4 times something times the 10, so that will give you 40, in theory that's going to give you 40L. Okay, and you're going to subtract from that 4 times L times 7, which is going to give you 28L. Okay, and if you subtract those, that's where the 12L comes from. Okay, so the length, so there's a length of 12 difference. So obviously now we've got a basic algebraic expression. 12L equals 150, so L is 12.5. Looking at the multiple choice answers that you've got, it has to be answer D. Alright, so we're doing question number 9, which is example 4. This one's not quite as difficult as that one. But what we got, okay, it tells you that a rectangular lap pool measures 80 feet by 20 feet wide, and it needs to be filled 4 feet deep. And then it tells you that each cubic foot is 7.5 gallons, and the question is asking you how many gallons it will take to fill the pool. Alright, so don't forget the area is equal to the area of the base times whatever the height is, so it's just purely and simply a multiplication this time. So you've got your 80 for the length, you're going to multiply that by the width, which is 20, and you're going to multiply that by the depth, which is 4. Okay, so 80 times 20 is the base and 4 feet deep, and if you multiply those together you get 64 or 6,400 or 6,400 feet cubed, and don't forget this time it's cubed. And then it says that each cubic foot holds 7.5 gallons, so again it's just a multiplying situation here. So your 6,400, if you times that by 7, you finish up with 48,000, and looking at your answers you've got, that has to be answer D.